So since we're trying to get rid of our denominators, I need to look at what my factors are in the denominator and then multiply both sides by that. So what I'm going to do is I've got this factor of x and this x minus 3. So I'm going to multiply both sides by that. And again, show all of your work. That way you don't mess up with where it's going to go to because it has to go to everything. So then my next step is x cubed plus 3x minus 9. And then I multiply that by the x and the x minus 3. But its denominator right now is x and x minus 3. I haven't canceled anything out. I will, though, in a minute. And then I have this x plus 6, and it gets the x and the x minus 3 over its denominator of x minus 3. And then the 3 gets the x and the x minus 3, and then that's still over its x. So all I did was show all of my work to multiply through the numerator. And so now I'll simplify out those forms of 1. So the x over x is a form of 1. The x minus 3 over x minus 3 is a form of 1. X minus 3 over x minus 3 and x. So I have no more denominators left. Don't multiply by too much. So even though I have like 2 x minus 3's in the bottom, I only have to multiply by 1 x minus 3 because it's going to cancel each of those out since I'm distributing it over subtraction. So then in the first fraction, I'm left with x cubed plus 3x minus 9. And then I'm subtracting that x times x plus 6. And then that equals the 3 and the x minus 3, so 3x minus 9. You have to be really careful with this one because of the subtraction. So I'm subtracting this whole thing. So one thing you might want to do is change that subtraction to plus the opposite. And then you can go ahead and send through that negative x. That way that subtraction sign goes all the way through. So then you get x cubed plus 3x minus 9, and then minus x squared minus 6x. And then I'm going to set this equal to 0. So minus 3x plus 9 equals 0. This might be also where you might mess up in number 4 because there's a subtraction in number 4 as well. And then I combine all my like terms, so I only have 1x cubed, and then, uh-oh, I lost my x squared. Oh, there it is. And then I have 1x squared, and then I have positive 3x's, and I have negative 3x's, so that's 0, and then minus 6x, and a negative 9 and a positive 9 is 0. So this had to happen because you don't know how to factor a higher degree polynomial, like a cube or a fourth, unless you can factor out a greatest common factor. So now I can factor out that x. And x times what is x cubed? Well, that's x squared. X times what is x squared? That's minus x. X times what is negative 6x? That's negative 6. And then one of the things that we talked about is because the leading coefficient here is 1, being able to shortcut that factor. So one of your factors is x. But now, because that leading coefficient's 1, I can shortcut it. So my product is negative 6 times that 1x squared. So my product is negative 6. My sum is negative 1. So what two numbers multiply to give you negative 6 and add to give you negative 1? Negative 3 does, and positive 2. Double check. Negative 3 times positive 2 is negative 6, and negative 3 plus 2 is negative 1. It works. So set each of those factors equal to 0. X equals 0, x minus 3 equals 0, and x plus 2 equals 0. So there's the first one, x equals 0. Add the 3 over, subtract the 2 over. So those are my 3 values of x. However, if you looked at the answer key, you'll notice that those aren't my 3 answers. So 0, 3, and negative 2. Now I have to go back to my original problem, and I have to check to see what works. We know that we can't have a 0 in the denominator. So if I put 0 in the denominator, that's 0 in my denominator. If I put 3 in for x, that makes this denominator 0. It also makes this denominator 0. Again, you can't divide by 0. So therefore 3 is extraneous as well. And then negative 2 works. So my only answer is x equals negative 2. Good. Now, if that's enough, maybe try number 4 and 5 to see if you can figure them out from there. I'll just give you a couple of tips otherwise too. So you have to factor this and factor this so that you can see what your denominator can't be. So the first one is the difference of two squares, so x minus 3x plus 3. And in the second one, when I go through and factor that, I end up getting x minus 3x minus 3. And on the right-hand side, I get 2 over x plus 3. So now when I multiply both sides, I know I'm going to have to multiply by an x minus 3 and an x plus 3. So when this distributes here, is that going to cancel out both those denominators? Yep. How about over here? No, because I have 2x minus 3's here. So not only do you have to multiply by x minus 3 and x plus 3, you also have to multiply by another x minus 3. So really what you're multiplying by is 2 factors of x minus 3 and 1 factor of x plus 3 on both sides. So try that from there and see if that helps you get through it. Number 5, for this one, there's nothing too tough about this one. The only difference is your solution is no solution in the end. I don't know if that's what's catching you. So you got to factor that denominator. So product is negative 6, sum is positive 1, which means it's an x plus 3 and an x minus 2. So then you're going to multiply both sides by x plus 3 and x minus 2. So that gives us 3x, x minus 2, x plus 3 over x minus 2 plus 2x, and you get an x minus 2 and an x plus 3 over x plus 3. And then you get 30 x plus 3x minus 2. Doesn't matter which order you put your factors in. Over x plus 3 and x minus 2. Find all those forms of 1. And then you're left with 3x times x plus 3 plus 2x times x minus 2 equals 30. If that was enough, keep going through the problem. Otherwise, I'll just finish it up here. So that's 3x squared plus 9x, distributing that 3x through. Distributing the 2x through gives you 2x squared minus 4x. Subtract the 30 over. So that's an x squared plus 5x minus 30 equals 0. I knew I messed something up. That's a 5x squared there. Greatest common factor. Factor out of 5, and you're left with x squared plus x minus 6. And factoring that, product is negative 6, sum is positive 1, so it's x plus 3 and x minus 2. You might have to take a little more time than that. But they do start to come a little bit quicker when that leading coefficient is 1. So negative 3, positive 2. When you put negative 3 in, it makes that denominator 0. When you put 2 in, it makes that denominator 0. Therefore, they're both extraneous, which means you have no solution. And what I probably wrote is the 0 with a slash through it, which means the null set. Okay, good luck.